Okay, our number 5, and it's evaluate a limit where x is in degrees, and I do see the limit. And these are kind of disturbing problems to me because I don't think we should really use degrees, although I do speak degrees over radian when I'm talking trigonometry. But it really causes tremendous problems in mathematics, by the way. All right? So I'm going to go to the whiteboard, and I want to write it down. It's number 5. And the limit as x in degrees is going towards 0. And it's going to be sine x over x is equal to. Well, one thing I do know this limit here. I know the limit when x is a real number, pure number, goes towards 0, sine x over x is 1. I do know that much, all right? But I'm going to say this is not that problem. Right? It's a different problem. Right? X is a degree measure. So what I'm going to talk about, what it looks like to me when you're in degrees. And the sine function, it looks like this. It still looks like the same. But now I got degree measures over here. So this would be 180 degrees. This would be 90 degrees. This would be 270 degrees. This would be 360 degrees. And what I want to do is I want to get a line that looks like that. It fits that description. So I do know the line looks like y equals mx plus b, and the b is easy for me. It looks like 0, right? So y, I got to figure out the slope, right? I have to figure the slope out in that one over there. So I'm kind of looking at it, and it's not easy, right? Looking at this thing, I always get confused. You get degrees down here. What do you do? And I'm looking at this thing over. Oh, by the way, this is the number 1 up here. That's the number 1. All right? So looking at that, I'm going to say my line, the slope of that line, dump the m now, is going to be pi over 180. Well, I'm not going to put degrees down there, by the way. Let me get the eraser out and erase that. I'll put down 180. All right, so I definitely get 0 there. Right now, someone says, why'd you pick that number there? Well, if I put 90 degrees there, what would I get? I get pi over 2, which is what I wanted to get, right at the 90, pi over 2. All right? So let's write this down now. So I'm going to write down the limit when x is in degrees, going towards 0, of sine of x over x equals the limit x is in degrees going towards 0. I still have to use the sine of x, by the way. But I want the bottom to look like this. Now, for that to occur, I've got to multiply. I got to do something here, right? And how do I do that now? I guess pi over 180, right? Whoops, I just keep doing that degree business there. I got to get rid of that. Let me see if that's true. Yeah, that works out beautifully. It gives me back exactly what I have over here. And I'm going to pull that out now. And what do you get there? You get pi over 180 times the limit. X goes to 0. X in degrees goes to 0. Sine x over pi 180x. And by the way, when I do that, let me get my eraser out again. I keep doing weird things. What does this give us? This now, they're both going towards 0 at the same rate, by the way. This gives me 1 now. Right, so what do we get over here? We get pi over 180. All right, and that's it. We're done with that problem. Thank you.